Some of the biggest black holes ever recorded in the history of science have gobbled up over 20 billion stars. If there's one thing we know is true but simply doesn't seem true, it's the concept of black holes. They're incredibly mysterious phenomena in the universe that we've never quite understood, yet they fascinate us. In fact, if you want to see a black hole tonight, go outside and look in the direction of Sagittarius. That's where we have the center of a galaxy, and a black hole weighing perhaps 2 to 4 million times the mass of the Sun is lurking right at the center of our own backyard. There's nothing quite as powerful as a black hole in this universe. Being a mixture of space, time, and matter all wrapped up in a single point, they have the capability to absorb anything that comes into contact with them. But while we know they're extremely powerful, we haven't really understood many of the specifics behind them, until now. This photograph is the smoking gun. First of all, the black disk in the center is the event horizon, the point of no return. You fall through that event horizon, and you never come out. Scientists have been studying black holes for decades, and they've finally figured out the inner workings of one. Join us as we discuss what it's really like inside a black hole and how this discovery might just change everything. But before we get to the current discovery, we need a bit of background. Even though most of us grew up knowing that black holes were real, there was a time when they were just a theory. That was until the first black hole was discovered in the late 1960s, known as Cygnus X-1. From this discovery, scientists gained some insight into how black holes work and behave. For instance, they found that a black hole is an incredibly dense area of spacetime with such immense gravity that nothing, not even light, can escape from it. They also discovered that black holes come in different sizes, with the biggest ones being around 200 kilometers across. The smallest ones are tiny, about the size of an atom. Cygnus X-1 is a stellar mass black hole, which means it's only 6 times bigger than our Sun but has the same mass. The discovery of Cygnus X-1 also revealed that black holes tend to have strong magnetic fields as well as a powerful gravitational pull. This makes them incredibly dangerous and capable of causing serious destruction in the universe if left unchecked. This discovery enabled researchers to learn more about how these powerful cosmic objects work and to develop theories that allow us to better understand these mysterious phenomena. From this discovery, we were also able to find out how rare black holes actually are. It turns out that there may be close to over 1 million black holes in the Milky Way alone, yet they are still incredibly hard to detect, leading many to speculate that the actual number could be significantly higher. If there are that many in our own galaxy, we need to learn more about them. Thus began the journey to truly understand what's inside a black hole. In essence, when something enters a black hole, it is trapped and compressed astronomically until it reaches a singularity, the main mass point of the black hole where all matter is crushed into a single particle. Before reaching this point, however, there are 2 layers of a black hole that one must travel through in order to reach the singularity. The first layer is known as the outer event horizon, a boundary surrounding the mouth of the black hole where anything entering will not be able to escape due to its incredibly strong gravitational pull. This layer is responsible for trapping and slowing down anything that falls into it, so much so that to escape would require traveling faster than the speed of light, an impossibility in our current understanding of physics. This is also the point where the physics of our universe stop working, replaced by a new set of chaotic laws that govern what happens inside. The second layer is known as the inner event horizon, which acts as a gateway leading toward the singularity. This is where the real danger lies, as once a particle enters this layer, it has no chance of surviving or escaping and is almost certain to be crushed into a single point of matter. At this point, gravity is so powerful that it bends light itself, while time slows down, and temperatures become unimaginably hot. So not only is matter being crushed, but it's also being boiled alive. What makes black holes so dangerous is that they have completely different gravitational pulls, making them incredibly difficult to study and predict due to their unpredictable nature. The thing that makes them even worse is that due to the incredibly strong gravitational pull within and around a black hole, it is impossible to observe them directly. Scientists have to rely on observing stars that orbit nearby these entities in order to gain any meaningful information about what lies inside them. Think of it this way, you've got this overwhelmingly powerful thing in space that you need to know about, but it exists in 3D, while we can only study it through telescopes and pictures, which are all in 2D, without ever going inside. As we've established, once you go in, there's no coming out. But that's not all. The problems with studying black holes stem from a fundamental impossibility: we can't travel fast enough to escape their gravitational pull. This means scientists are essentially limited to studying them from afar, which is challenging given the sheer size and complexity of these phenomena. To do so, they have to observe the radiation black holes emit and the dust and gas that surround them. This makes it incredibly difficult to create a detailed image of what's inside the black hole, as any probes or cameras sent into space would be instantly crushed by the event horizon once they reach it. Further complicating matters is the fact that every black hole is unique in its own way, meaning there's no single standard model for how they form and behave. On top of this, physicists have so far been unable to make sense of the singularity that lies at the center of all black holes because we simply don't possess the technology to travel fast enough to reach it. This means all we can do is theorize about what might lie within, but nobody will truly know until we find a way to transcend the boundaries of spacetime and travel faster than light. To add even more difficulty to the situation, black holes are constantly changing and evolving as they absorb matter, energy, and radiation from the universe around them. This means that whatever data scientists may have gathered from observing a certain black hole at one point in time could easily become outdated as the black hole continues to transform over time. Despite the danger and mystery surrounding these massive astronomical phenomena, they can still be studied and understood to an extent. By mapping out stars close to the event horizons of black holes, scientists are able to observe them from afar and gain valuable insight into their structure and behavior. This knowledge has allowed us to further explore space safely and develop theories about what lies beyond the event horizons of these mysterious entities. As scientists have done just that, several particular theories have come up, and this is where things get really interesting. One theory about black holes suggests that they are not just huge masses of nothingness but instead could be gateways to other galaxies and universes. This idea is based on the movie Interstellar, where characters travel through a black hole to find a new home for humanity. If this theory holds true, black holes could provide us with a gateway to faster-than-light travel. This would mean we could navigate through them to reach galaxies and universes beyond our own, not limited by the constraints of space and time. However, this theory remains highly theoretical, relying on creating technology capable of faster-than-light travel. But that's not all. There are other problems. For instance, due to the gravitational pull of a black hole, any spacecraft entering it would become trapped and unable to escape. This means traveling through them would require extensive research to avoid such a catastrophic event. In addition, the immense radiation that comes from black holes could also be dangerous to any spacecraft traveling through them. Plus, it is still unknown what else may lie beyond the singularity of a black hole. However, scientists are already working on creating a spacecraft that can travel faster than light. If they manage to create such a spacecraft, chances are black holes might be one of the first things we explore more deeply. While there is enough proof that holograms are indeed real, studying these mysterious beasts of energy is still extremely difficult. So, Enrico Rinaldi set out to simplify the entire concept. He wanted to approach things differently, and he did so by combining two of the most common theories about black holes, particles and gravity. When combined, they are known as quantum matrix models. Rinaldi went further, proposing a new theoretical concept now known as holographic duality. This theory suggests that when we observe a black hole in space, it should be viewed as a hologram. The essence of this theory lies in the idea that the outer space around a black hole plays an important role in its function. It's not just a singular point where all matter compresses, but instead part of an ongoing cycle of energy. According to Rinaldi, the particles and gases found in outer space provide the fuel that powers a black hole. In other words, when we look at a black hole in the form of a hologram, we can see how all these elements interact to create something new. This is a much different picture than what has been previously suggested about black holes' behavior. Instead of a singular point where all matter compresses, we should consider the possibility of a moving black hole, constantly consuming dust particles and gases from its surrounding space, which helps power it further. This means that even if a black hole were to move near a planet, it could still consume its matter and continue growing in size. The implications of this new theory are exciting, as they could lead to the development of a better understanding of black holes and their behavior. If we were able to unlock the secrets within these mysterious objects, we might even be able to use their energy for our purposes. It's still uncertain whether this theory is correct, but it provides a much more exciting look at these powerful objects. As technology advances and we continue learning more about black holes, the possibility of unlocking new secrets remains open. Only time will tell what discoveries lie ahead, but from what we've already learned about black holes' inner workings, chances are things will only get more interesting. And when they do, we'll be the first to talk about it here. And on that note, we'll wrap up today's video. What's your theory about black holes? Let us know in the comments below. If you liked this video, please give it a thumbs up and subscribe to our channel for more videos just like this. We'll see you in the next one.